In this video, we are going to dive a little deeper into exponents and what's going on with them. In particular, we're going to introduce exponents attached to variables and what do we do about that. So for example, let's say we have 2 to the third versus x to the third. With 2 to the third, I can evaluate that because I can multiply 2 times 2 times 2 and get that its value is 8. With x to the third, there's not really anything I can do with it because I don't know a value for x. I can't take that times itself 3 times, literally. So we end up just having to represent it symbolically as x to the third, and we say that that's as simple as it can get. So we're going to look at problems that aren't as simple as they can get and simplify them down as much as possible. So let's say we have example 1 here. Notice how I've changed the directions from evaluate to simplify. Because evaluate means find a value. Simplify just means do what you can to make this expression simpler. So in part A here we have x squared times x to the third, and we want to try to simplify this down some. Well, remember, x squared means x times x, and x to the third means x times x times x. The exponent is just counting how many times we're multiplying those things. So if we multiply two multiplied things together, we're just totaling up how many x's are being multiplied there. So all in all, we have 5 x's being multiplied, so this is x to the fifth. And that's basically how it's going to work, is if you have things that have the same base, so here our bases are both x's, and they're being multiplied, then we can just total up their exponents, because that's the total number of those bases that are being multiplied. Okay, now let's change it to division. So we haven't really looked at this yet, so I haven't had a chance to emphasize it, but when you have a fraction bar always means division. So fractions are just another way of saying division. So I look at this as x to the third divided by x squared. Now if I expand that out, like I did in that first example, x to the third on top, or in the numerator, is x times x times x. And then x squared in the denominator is x times x. Now anytime you have a number divided by itself, that equals 1. 2 divided by 2 is 1. 3 divided by 3 is 1. Well, x is a number, so x divided by x is 1. So that x right there divided by itself is a 1. This x right here divided by itself is a 1. So how this simplifies down is you have 1 times x, which equals just x. A lot of times we say the x's just cancel off, but what's really happening when we're saying they're canceling is that they're dividing down to 1, and then those 1s get absorbed into the multiplication of the problem. Going back to our original problem we had here on part B, basically what's happening there is you don't have to write it out the long ways like I did. If you can imagine in your head, you have 3 x's being multiplied on top and 2 x's being multiplied on bottom, and they're going to annihilate each other 1 for 1, then you're going to have 1 left in the end, and it's going to be left on top. It's kind of like it's the winning team. And so we have x as our result. Alright, so here in part C I switched it up. Now I have 2 x's on top and 3 x's on bottom. I'm going to write this out the long ways, but again, you guys don't have to show this step. This is just because we're figuring out what's going on. My hope is that eventually you would get to where you could see that expansion in your head. And then we're going to annihilate 1 on top for 1 on bottom. As we're going to divide down to 1. Now in this case, we have the winner is on bottom. The extra x that didn't get canceled off or annihilated is on bottom, and it needs to stay there. Okay? And then that leaves the top completely empty. And so what's really there is a 1, because remember, these are 1s. Okay? And down here in part B, they got absorbed into the multiplication, but in part C, there's not anything to absorb them, and so it's left as a 1. You could make an argument in part B that this x is over 1, but x divided by 1 is just x. However, 1 divided by x is still 1 divided by x. So that's why we're left with the 1 on top in part C. So general rule is for B and C is when you're dividing like this, they're going to cancel each other off 1 for 1, and then wherever the bigger exponent is, that's where the winners get a say, or where the leftovers are. Whereas when you're multiplying, like we did in A, if the bases are the same, we're just totaling up the total number of exponents because they're multiplying together. Division cancels out that multiplication, makes the exponent smaller. Multiplication increases that multiplication and makes exponents bigger. Alright, here we just fancied it up a little bit by adding in more components, but don't let that scare you. Basically, everything here is multiplication. The stuff in the parentheses is being multiplied, because when you glue two things next to each other in math, that's multiplication. And then the stuff, each group is being multiplied, because between the parentheses there's not an operation symbol, and so that's multiplication. Anytime you glue two things together, it's going to be multiplication. So the nice thing about multiplication is you can reorder things at will. So I can rearrange this as x times x to the third, y squared times y squared. And you don't have to literally write that out. You can do that reassociation in your head. But the reason why we did it is because the items with the same bases are going to combine with each other. Next one, it tells us how many times we're multiplying by a specific base. So if the bases are different, they can't combine. But if the bases are the same, those can combine. So the x's, there are 4 x's, and the y's, there are 4 y's, but for different reasons. Okay, so that's all you do when there's more than one variable in the expression, is you multiply together the ones you can, or the ones that are the same, and then glue them together. Alright, so this is basically like A, except I threw in some numbers in front here. These numbers in front that aren't exponents, those are called coefficients. The numbers in front of variables are called coefficients. So now we have those. But remember, everything's just multiplying here, and we can reassociate similar things. And you can do this reassociation in your head, but since you can't see what's going on in my mind, I'm going to write it out. So I'm going to take the 2 and the 3 and put them together, because they're just regular numbers, so they associate together. And then I'm going to associate the x's together, and I'm going to associate the y's together. And again, I would actually just do this in my head if I weren't showing you the work so you could see what was going on in my head. So now I'm going to actually do the multiplication, and so 2 times 3 is 6. I have a total of 6 x's being multiplied, and I have a total of 4 y's being multiplied. And that's all there is to it. Alright, now I'm going to do one of these more complicated ones as a division problem. So with this, the same idea with the association is if they're the same type of thing, we're going to associate them together. So the 4 and 2 are both coefficients, so we'll associate those together. The x's will associate together, and the y's will associate together. But we need to remember that here we are dividing, not multiplying. So exponents tell us how many times we're multiplying, so when we divide, that's going to reduce how many times the multiplication is happening. So I'm going to skip over the 4 and 2 coefficients because the x and y stuff we've already talked about. So for my little blue bubble there, I have 3 x's on top and 1 on bottom. So one of those will get annihilated, and there's going to be 2 extras left on top. Whereas with the y's, I have 2 on top and I have 5 on bottom, so after they get done duking it out, I'm going to have 3 y's left on bottom. Okay? So that's what's happening with the x and y's. Now let's look at the 4 and 2. With the 4 and 2, these are just regular numbers. Just like we did over here in part B, when we had a 3 times a 2, we just multiplied it. Well, this is a 4 divided by 2, so we're just going to do that division. So 4 divided by 2 is 2, and that result will be on top. You can just think of it that you're reducing it like a fraction. So if, hypothetically, I'd had a 2/4, then when I reduced that, I would have had a 1 on top and a 2 on bottom. Okay, so I'm just reducing it like I'd reduce a fraction when they're coefficients. Alright, so that's all jumbled up because I did it in stages. So the OCD in me is going to make me write it more balanced so that it looks like that. But it is done. Okay, now we're going to up the ante just a little bit more on our exponents part 2. And what we're going to do is look at when we have basically what I call a power to a higher power. For example, let's say we have x squared and then it's raised to a higher power of 3. So 2 is a power and 3 is a power. So it's a power to a higher power. Now, literally what this means is the 3 outside tells me to take everything inside the parentheses times itself 3 times. So let me write that out explicitly. So we would have x squared times x squared times x squared. So everything inside the parentheses times itself 3 times. Once we write it out like that, then we'll see that it's actually kind of like the stuff we were just doing. How many total x's are happening there? Well, if we total up the number of x's being multiplied, it's going to be x to the 6th. Okay, and you might notice there that we end up just multiplying our exponents. Now, I want you to be careful with that and not get too abusive of it, but that's really what's happening, because if you have 2 things and you repeat it 3 times, then you're going to have a total of 6 things. Alright, in part B, I'll explain what I meant by I don't want you to get too abusive about it. So here, we are repeating everything in the parentheses 3 times. So this means 3y to the 3rd times itself 3 times. Well, I have a total of 9 y's there. So that's going to be y to the 9th, if I can get it written here. Okay? Now, if I take 3 times 3 times 3, because these are coefficients, so I'm literally doing the multiplication, that's going to be a 27. Okay? So when you're doing this, and I know you guys will start to see the patterns, you're going to take the power to the higher power, you multiply those powers, and that'll give you the result. But you never do that when it's a coefficient, okay? A coefficient is a base, and so there you just take 3 to the 3rd. So it's not 9, it's 27. So hopefully you're seeing the distinction there. You treat bases very differently than you treat exponents. So any of these interactions and any of these patterns you're seeing connect for exponents do not apply to coefficients. They're totally different types of numbers. Alright, this one's about the same, except we have a coefficient and 2 different variables. But still, I mean, if you think about it as that it's 2xy to the 4th, everything in the parentheses, times itself 3 times. Alright? And like I was saying in the previous example, I don't actually expect you to write all that out, but as we're learning, it's helpful to see what's going on. So I have 3 2's being multiplied, so 2 times 2 times 2, that's going to give me an 8. I have an x, I have another x, and another x, so that's going to be x to the 3rd. And then I have y to the 4th, 3 copies of that is going to give me y to the 12th. So this step here, if it helps you to write it out, by all means write it out, but it's not necessary. I'm okay with you to just go to this result there, where essentially what you're doing is taking your exponent and applying it to each of these types of factors inside the parentheses. In a sense, you could say we're distributing the exponent to each factor inside the parentheses. Okay, well that is what I have for exponents part 2. Go ahead and practice some problems on this and see how it works out for you.